On the 28th and 29th of May, the Prat la Riba Hall at the Institut d'Estudis Catalans was filled with neuroscientists. This was BARCCSYN, the Barcelona meeting on computational, cognitive and systems neuroscience, in its 14th edition. BARCCSYN is the annual meeting point for computational neuroscience in Barcelona. It's organized by the Centre de Recerca Matemàtica in collaboration with the Computational and Systems Neuroscience section of the Catalan Societies of Biology and Mathematics. The idea behind it is plain: get the city's research groups into one room and keep the people who build models talking to the people who run the experiments. This year, it brought together 117 participants, 11 talks from local researchers, 3 keynote lectures, and 63 posters across 2 sessions. 2 long coffee breaks did the rest. The first keynote came from Raoul-Martin Memmesheimer of the University of Bonn. His question: how can a memory last when the neurons that hold it keep changing? His answer turns the usual picture around. The groups of cells that store a memory don't stay fixed. They remodel completely over time, swapping neurons in and out, while the memory itself slowly drifts. And he argues that this drift is doing the real work, settling a memory in and spreading it through the brain. Saskia Haegens of Columbia University looked at brain rhythms, and at the beta rhythm in particular, the activity between 15 and 30 Hz. Working with recordings in primates and in human volunteers, Haegens showed that shifts in this rhythm in the frontal cortex carry the outcome of a decision and can even predict what a person will do. On this view, the beta rhythm does real work. It switches the brain's communication channels on and off as a task demands. The third keynote went to Sara Mederos of the Hospital del Mar. She studies how animals decide what to do when they're afraid. In her experiments, mice react to a dark shape looming overhead, the way they would to a bird of prey. At first, they flee. With repetition, they learn to hold still. Mederos traced that learning to a small hub deep in the brain and showed how stress can leave marks on memory circuits long after the threat is gone, with possible links to anxiety and PTSD. Between the keynotes, the range was wide. Memory and how it drifts, how the brain weighs evidence before a choice, perception flipping between 2 readings of the same image, maps of space in the hippocampus, brain rhythms, whole brain models, and clinical work on epilepsy and seizures, theory and experiment side by side. Much of that work came from younger researchers, presenting posters and giving some of their first conference talks. The CRM was well represented, with 3 talks and 8 posters, on subjects ranging from aging and memory to motion perception and the question of how stable neural patterns survive constant change. At the close, 3 contributions were singled out. Melanie Cheers from IDI-BAPS took the prize for Best Talk for her work on working memory. The 2 poster prizes went to 2 more IDBAPS researchers, Thomas Morvan and Katerina Barezzi, both for work on how the brain makes decisions, from deliberation in mice to foraging. By the evening of the second day, after the prizes and a quiz, the meeting wound down with a reception. 14 editions in, BARCCSYN keeps doing what it set out to do, getting Barcelona's neuroscientists into one room once a year to argue about how the brain works.